In the latest version of ResSim, which is ResSim version 3.3, you have the opportunity to do Monte Carlo analysis. Now, Monte Carlo analysis allows you to build models of possible results by substituting a range of values for any parameter that has uncertainty, as opposed to just using a single value for that parameter. So I'm going to show you in this video is the mechanism for setting up a Monte Carlo analysis within ResSim. So as you can see, I have a very simple model. It has one reservoir, and we can go take a look at this reservoir. I have just one outlet on this reservoir, and I have just one rule on the reservoir. I have a maximum release rule that's applied both in the flood control and in the conservation zones, and that maximum is 900 CFS. I also have inflow coming in at the upstream end of the main stem and also at the upstream end of this tributary, which is required for ResSim simulation. And we can go look at that junction. You can see that I named that main inflow and I applied a factor of 1 to it, which just means that the inflow values that are in the database or the inflow values that I want to use are basically they're being multiplied by a factor of 1. Now, to set up a Monte Carlo analysis, you do this in the alternative editor. And if you set up other ResSim runs, this should look very familiar to you. They have a lot of the tabs that are in all of the ResSim alternatives, all the ResSim simulations that you've probably set up. But then as new features are added, then they add these tabs to the end. But we'll start here at run control. So I'm using a time step of 1 day. I have operations, and you specify which operation set that you're using for the different reservoirs. I only have one reservoir, as I showed you earlier. I have that main stem reservoir. And so I do specify which operation set I want to use for that. I have my look back data in this case I have look back for the elevation of the main stem reservoir and also the release at the main stem reservoir. And then I have the time series, and this is the time series of inflows that are coming into the model. So remember, I had those inflows on the main stem and also on a tributary. So we can go look at this, and you can see that these are inflow values from, looks like from the 1940s all the way up until sometime in 2021 or 2022. I don't use all of that data. You can see over here I just have a very short simulation from, it looks like 20 May 2016 to 05 June 2016. You just want to make sure that the data that you are inputting into ResSim does cover both your look back and your simulation time period. So if you've done other ResSim runs, then those tabs should look familiar to you. One that might not look familiar to you would be this Monte Carlo tab. So if you're doing a Monte Carlo simulation, actually I think I need to go back to run control to show your alternative type does have to be checked or filled in for Monte Carlo. And if you're doing a Monte Carlo simulation, you would then click the Monte Carlo tab and you see that you have 3 additional tabs down here. You have input variables, output variables, and then MC or Monte Carlo controls. So if you want to add an input variable, and by the way, the input variable is going to be a variable that you're wanting to apply the Monte Carlo analysis to, or a parameter that you want to apply uncertainty to. So then you would just hit add and go ahead and start adding in the data for that parameter. So in this case, I've used 2 different parameters. I took the time series multiplier, and if you remember, that's the factor that we applied to the inflow, and it was 1.0. And I'm also going to apply it to that one rule that we had, that maximum release rule. And we can go ahead and edit that just to take a look at it. So if you hit add, then this wizard would come up, and it would walk you through step by step. And it would ask you, what is the random variable type? In this case, the first one was a time series multiplier. You can have input time series, reservoir rule parameter, look back value, rating curve, or you can even do a script variable. In this case, we're just doing this inflow multiplier. We only had the one. I actually used the same one for both the main stem and the tributary, but if you had multiple ones, then those would pop up and you would be able to pick that out. The reference dependency, that is that's basically how the Monte Carlo analysis is going to relate back to the original variable. It can be absolute or relative. And then you have time dependency, so you can have it be a constant distribution parameter or a seasonal distribution parameter. And I just set it for constant for this one. You have different distribution types, and I just picked one and I just let it default to whatever parameters it filled in. So obviously this is not a realistic analysis. I do recommend that you get with someone who's very knowledgeable about statistics to help out with this Monte Carlo analysis if you decide to pursue this through HEC-ResSim. Again, this is just showing the mechanism. This is not a realistic analysis. And then we can say that we're finished with this one. We can also go look at the rule parameter. So we can look at the different steps. So here we picked out the reservoir rule parameter. And if, remember, we only have one rule in the model, but if we had more, then all of those rules would open up and you can pick multiple rules if you want. But in this case, I just chose my one rule because I wanted to be able to apply some uncertainty to that maximum release value. So I don't want it just to be set at 900. And again, you have your reference dependency and your time dependency, which we discussed earlier. And again, I just set the distribution type to log normal and just left the parameters as is, whatever HEC-ResSim defaulted to. I'm not recommending that you do that. I'm recommending that you perform the analysis to find out what those distribution parameters are. But again, this is just for the mechanism of how to do it in HEC-ResSim. So those are our input variables. And if we go look at our output variables, basically what HEC-ResSim wants to know is what variable are you interested in knowing the impacts of this uncertainty. And so in this case, I chose the pool elevation. It looks like the statistic I use is the maximum. So I want to know how is the maximum pool elevation affected by this. So we can go in and look at this. If you pick something on the reservoir, then, if you once you have this output variable wizard, all of these locations are going to open up. And you can pick any of the parameters that are within the HEC-ResSim model and take a look at it. Here the statistic I use is the maximum, and I believe I just used whatever HEC-ResSim defaulted to for this to again show the mechanism of how this is set up. Finally, you run into the MC, or the Monte Carlo controls, and you can have a minimum number of iterations and a maximum number of iterations. And I think that's it. There's a data check here, so it'll let you know if there's any errors or warnings to report. And once you have that set up, we can save it. And then what we'll do is we'll go ahead and compute the Monte Carlo analysis. And you can see it's computing these realizations. Now, I put in a minimum of 200 or a maximum of 300. And as you go through, you might see that it converges quicker than what you thought. So you might be able to reduce that. Or it might take longer to converge. So you may have to increase it, just depending on what it is that you're trying to get out of the model. And you can see it successfully ran. It looks like that it did go to 200. So I had a minimum of 200, a maximum of 300, and it just needed the minimum in this case. So if we want to go look at the results of this, you go to Reports and then Monte Carlo. You can look at the histogram, and this is for the global inflow multiplier. And on the x-axis, it's showing those values for this inflow multiplier. On the y-axis, it shows the frequency. So it looks like there's a range between 0.3 all the way out to about 3.3. I look down here and there's a running average of about 1.056. So pretty close to the value of 1 that we used. You can also look at the maximum release rule. If you remember, that had a 900 value, and it looks like that, unsure of what this is, it may be 300, 250, something like that, all the way out to, looks like beyond 3,500. The running average appears to be close to our 900 value, but just slightly above it, 939 or 940. We can also go look at the convergence plots. And two things I wanted to point out. Number one is up top, you can see that for every one of these realizations, you get a maximum pool elevation. And you can see that it varies from below 88 to above 94. You can also see, if you look at the red line, that is the running average. And you can see that it converges and doesn't really change, or it settles on an answer and doesn't really change, probably maybe about realization 40. And you can see that it's not changing very much, you know, as you get subsequent realizations that are run. And then finally, you can go look at the output report. And pull that up. And if you go to the bottom, there is a cumulative distribution function, and you can see that based on the results, this is what you would expect. It looks like that your 1% quantile would be 87.49, and then your 99% quantile would be 94.52, which relates very well to that first plot, or that top plot that we had looked at earlier. So basically, that's the mechanism for setting up a Monte Carlo analysis in HEC-ResSim. If you found the video helpful, please feel free to subscribe to the channel, and you'll get notification when more of these types of videos come out. And thanks for watching this one.